start. The question number 11 is exercise number 1.2. In the previous lecture, we learned about equation of tangent and equation of normal, and also the examples which is related to velocity, acceleration, and displacement. So here, question number 11 is the volume of sphere increases at the rate of 20 centimeter cube per second. By the given condition, here volume of sphere increases at the rate of 20 centimeter cube per second. It means that here the rate of change of volume with respect to time t is 20 centimeter cube per second. Means it is a changeable, volume is changeable. Means if V is a volume of the sphere, then we can say that dV upon dt is equals to 20 centimeter cube per second is a given part. So again, find the rate of change of its surface area. If we consider S be the surface area, then we can say that we have to find ds upon dt when radius r is equals to 5 centimeters. So it is clear that we have to find ds upon dt, and given condition dv upon dt is 20 centimeter cube and radius which is r is 5 centimeters. First we consider that let r be the radius of sphere. After that, S be the surface area of sphere. So after that, V be the volume of sphere. And we know that volume of the sphere, which is V is equals to 4 by 3 pi r cube. So first, by the given condition, or we can write given that rate of change of volume means dV upon dt is equals to 20 centimeter cube per second. Again, we have to find rate of change of its surface area means ds upon dt, and the radius r is equals to 5 centimeter. So we have volume of sphere which is V is equals to 4 by 3 pi r cube. Here r means radius. If we differentiate with respect to t, then we can write dv upon dt is equals to 4 by 3 constant function, or pi again constant function. We take a derivative with respect to t of r cube. Here, if we consider r is a differentiable function with respect to t, and if we take the derivative of r cube, we can write 4 by 3 pi into 3r square, again a derivative of r with respect to t, which is dr by dt. Here 3 get cancelled. We can write dv upon dt is equals to 4 pi r square into dr by dt. So given that rate of change of volume of surface increases at the rate of 20 centimeter cube per second, hence dv upon dt is 20 centimeter cube per second. 4 pi r square into dr by dt. Again here r is equals to 5 centimeter is also given. If we substitute the value of r, means we can write 20 is equals to 4 pi 5 square dr by dt. If we shift this 4 pi 5 square right side, left side, we can write dr upon dt is equals to 20 upon 4 pi 25. 4 1 25, 5 1 5. We can write dr upon dt is equals to 1 upon 5 pi. So which is 1. But here we have to find its surface area. Rate of change of surface area is ds upon dt. We know that yes, surface area of the sphere is 4 pi r square. So again, if we differentiate with respect to t, we can write ds upon dt means surface area increases at the rate of radius radius which is 5 centimeter. Therefore 4 pi into derivative of r square. We can write the derivative of r square 2r into dr by dt. We know that the value of dr by dt 1 upon 5. Value of r which is 5 we can write 4 pi 2 into 5 and dr by dt which is 1 upon 5 pi. Here 5 get cancelled. We can write 4 into 2 8 pi get cancelled. 4 into 2 8 means ds upon dt means rate of change of surface area, or we can say that the surface area increases at the rate of 8 centimeter square per second when the radius r is equals to 5 centimeter. So next one, example question number 12. So here question number 12 is the age of cube is decreasing at the rate of 0.6 centimeter per second. Here change is given but is in decreasing order, means 0.6 centimeter is the rate of change of age of cube. Here the age of cube is changeable in a decreasing order, means if we consider that age of cube any which is variable which is x, then we can write dx upon dt is equals to, in decreasing order means minus 0.6 centimeter per second. So first we consider that let x be the age of cube. After that we can say that dx upon dt which is minus 0.6 centimeter per second which is given part. So find the rate at which the volume is decreasing when the age of cube is 2 centimeter. So again we consider V be the volume of cube. So now we can say that again we consider S be the surface area of cube. Here by the given condition we can say that the age of cube which is x, the rate of change of x with respect to t which is 0.6 centimeter per second, hence we can write dx upon dt is equals to, is in decreasing order means minus 0.6 centimeter per second. Again find the rate at which the volume is decreasing. We have to find dv upon dt, rate of change of volume is what? Again decreasing when the age of cube is 2 centimeter means when x is equals to 2 centimeter is the given part. So we have volume of the cube is cube of its edge. We can write v is equals to x cube. Now if we differentiate with respect to t, we can write the derivative of u which is dv by dt, again derivative with respect to t of x cube. We know that if we consider x is a differentiable function with respect to t, and if consider that x is in form of t, parameter t, we can write derivative of x cube is 3x square and again a derivative of x which is dx by dt. But by given condition it is clear that dx by dt is minus 0.6, 3 into minus 0.6 square into dx upon dt which is when the value of x is 2 centimeter. 3 square is always positive, hence we can write the square of 0.6 whole bracket square is 3.6 into 2. So we can write 3.6 into 2 is 7.2 and the product of 3 into 7.2 which is, here x, the value of x is 2 centimeter, 2 square, and dx by dt which is minus 0.6. So Here we can write square of 2, which is 4 into minus 0.6. 3 into 4, which is 12 into minus 0.6. We can write 12 into minus 0.6, which is minus 7.2 dV upon dt, which is a required rate at which volume is decreasing at the rate of 7.2 centimeter cube per second when radius is 2 centimeter. So the next one, question number 13. A man of height 2 meter. 2 meter height, which is a man of height 2 meter, walk at a uniform speed 6 km per hour away from a lamppost of 6 meter height. The height of the lamppost is 6 meter. Again, here we have to find the rate at which the length of the shadow is increasing. Here we have to find length of the shadow is increasing. So first we consider that here one is lamppost, which is perpendicular to the land. It is land. It is lamppost. So a man of height 2 meter. 2 meter height rate man is here, walk at a uniform speed 6 km per hour away from a lamppost, which is a lamppost. If we consider that L be the length of lamppost and the length of lamppost is 6 meter. Here let L be the length of lamppost. Again, we can say that 2 meter heighted man given here, which is man, H be the height of man. H is equals to 2 meter. Length of lamppost here is equals to again 6 meter. Hence we can say that if the shadow of man and shadow of lamppost here O A B M B be the shadow of man which we consider by X, and again remaining part OM we consider M. Here we have to find the rate at which the length of shadow means 0 to B, rate at which rate of change of OB means X and Y, X plus Y. Here we have to find clear that rate of change of X plus Y or rate of change of OB. So by the given condition we can say that here length of lamppost L is equals to 6 meter, height of man H is equals to 2 meter. So again we can say that here the rate of change of uniform speed 6 km per hour away from a lamppost man, rate of change of OM means dy upon dt is given again. Dy by dt is equals to 6 meter per hour. So it is clear that here the rate at which shadow increasing, we have to find rate at which shadow increasing. Here we have to find dx upon dt is equals to what? So by the given condition we can say that 2 upon x is equals to 6 upon x plus y. we can write 2 by x is equals to 6 upon x plus y. So if we take x 2 into x plus y, right, left side we can write 2 into x plus y is equals to 6 into x. Here 2x plus 2y is equals to 6x. We can write 6x minus 2x plus 2y is equals to 0. 6x plus 2x which is minus 2x which is 4x plus 2y is equals to 0. If we divide to both sides, we can write 2x plus y is equals to 0. Hence we can write 2x is equals to minus y and x is equals to minus y by 2. Which is the value of x is minus y by 2. So here 6x plus minus 2x minus 2y. Minus get. If we shift this minus y left side, right side, we can write plus y. Here x is equals to y by 2. So if we differentiate with respect to t, we can write dx upon dt is equals to 1 by 2 get constant and derivative of y which is dy by dt. But by given condition, the rate of change of y with respect to t which is dy by dt is 6 meter per hour. We can write 1 by 2 into 6 meter per hour. Hence 2's 1, 6, 3. The value of dx by dt is equals to 3 kilometer per hour, which is the rate of change of height of man with respect to time t is 3 kilometer per hour. So the next one, which is again example question number 14. A man of height 1.5 meter walked toward a lamp post of height 4.5 meter at the rate of 3 by 4 meter per second. Find the rate at which the shadow is sorting and the tip of the shadow is moving. So first we consider that let this is a lamp post which is perpendicular to the land OA. Here from tip of the lamp post up to point B is shadow of lamp post. The height of lamp post, we consider that L is equals to 4.5 meter. Again, the height which is 1.5 meter, man, MN. Let S be the height of man which is 1.5 meter is given. So let's we consider that shadow of the man which is MB be a x, distance of man from a lamp post which is y. Here we have to find his shadow is starting means rate of change of shadow of a man which is dx by dt, and the tip of the shadow is moving means rate of change of tip of the shadow which is OM MB, derivative with respect to t of x plus y is equals to what? So first we write L be the length of lamp post, H be the height of man, L is given, L is equals to 4.5 meter, H is equals to 1.5 meter. Again here given that the rate of 3.4 meter per second a man toward the lamp post means dy upon dt is again given. The value of dy by dt is 3 by 4 meter per second. So now we know that the ratio of HA upon x is equals to L upon x plus y. Hence we have L means 1.5 upon x, 1.5 upon x as to 4.5 upon x plus y, 4.5 upon whole shadow of lamppost, shadow of man, means shadow of lamppost, which is x plus y. It is clear that height of man upon shadow of man, the ratio of height of man upon shadow of man, the ratio which is given, both similar ratio of height of lamppost upon shadow of lamppost. So if we divide 1.5 both side, we can write 1.5 get cancelled, 1 by x is equals to 1.5 into 3, which is 4.5. We can write 3 upon x plus y. If we take 3 into x, 1 into x plus y is equals to 3 into x. If we shift this x right side, we can write 3x minus x is equals to y, which is 2x is equals to y. X is equals to 1 by 2 into y. If we differentiate with respect to t, we can write dx upon dt is equals to 1 by 2 into dy by dt. Again dy by dt is given, which is 3 by 4. We can write 1 by 2 into 3 by 4, which is 3 into 1, which is 3 by 8 meter per second. Rate of change of shadow of man with respect to time t, which is 3 by 8 meter per second. So, which is number 1? Again, we can say that derivative with respect to t, shadow of lamppost, x plus y is equals to dx by dt plus dy by dt. So here the value of dx by dt, which is 3 by 8 meter per second, plus value of dy by dt, which is given 3 by 4 meter per second. Here, if we take cross product or equal denominator 2 into 2, we can write 3 plus 3 into 2 6, 3 plus 6 upon 8, 3 plus 6, which is 9 by 8 meter per second, which is the tip of the shadow is moving. D or derivative with respect to d of x plus y is 9 by 8 meter per second. So the next example, which we have, a ladder 10 meter long is leaning against a vertical wall. So here, if the bottom of the ladder is pulled horizontally away from the wall of the rate 1.2 meter per second. Here we have to find how fast the top of the ladder is sliding down the wall when the bottom is 6 meters away from the wall. So here we consider that it is a wall which is distance OA. Again, this AB is a ladder. This is a ladder. Wall is perpendicular to land. Hence, here AOB is a right angle triangle. So, a ladder 10 meter long, the length of a ladder, which is 10 meter, are given, is leaning against a vertical wall if the bottom of the ladder is pulled horizontally away from the wall. Let us consider that bottom of the ladder, which is consider that x. So x be the bottom. The rate of 1.2 meter per second. Find how fast, means it is given that the rate of change of bottom of the ladder, which is the dx upon dt, is equals to 1.2 meter per second. Find how fast the top of the ladder is sliding down the wall when the bottom is 6 meter away from the wall. When the bottom is 6 meter away from the wall. It means that the bottom of the ladder is 6 meter away from the wall. Means here the value of x is also 6. So here we can consider that triangle AOB is right angle triangle. In this triangle, distance of AOB h be the height of wall, x be the distance from bottom of ladder to wall. Again, in a right angle triangle, triangle AOB, angle AOB is 90 degree. Therefore, by Pythagoras theorem, we can say that AO square plus OB square, AO square plus OB square is equals to AB square. AO square, which is h square plus x square, is equals to distance of AB, which is 10 square. If we shift this x square right side, we can write h square is equals to 10 square minus x square. We can write, if we take taking square root both side, h is equals to under root of 10 square, which is 100 minus x square. So here, if we differentiate with respect to t, we can write derivative of x, which is dh upon dt is equals to derivative with respect to t 100 minus x square. By using the under root x, which is derivative of root x is 1 upon 2 root of 100 minus x square into again a derivative of 100 minus x square. Derivative of 100 is 0, derivative of minus x square is minus 2x upon 2 under root of 100 minus x square, which is 2 to get cancelled. The value of x, which is 6. If we put this value of which is 6, minus 6 upon under root of 100 minus 6 square, which is 36, into dx upon dt, sorry, which is dx by dt. Again derivative, which is dx upon dt. The value derivative rate of change of dx upon dt, which is 1.2 meter. We can write 1.2 meter per second. Here minus 6 into 1.2, which is minus 7.2 upon under root of 100 minus 36, which is 64. It means that minus 7.2 upon 8 is equals to minus 9.2 meter per second, which is the required how far the top of the ladder is sliding down the wall when the bottom is 6 meter, which is minus 9.2 meter per second. We can say that 9.2 meter per second. So the next question number 16, which if water is poured at an inverted halocone. So for example, this is an halocone whose semi-vertical angle is 30 degree. Semi-vertical angle means here the angle between this, which is 30 degree. So here we can say that the angle of semi-vertical, which is 30 degree. So that its depth measured along the x-axis increases at the rate of 1 centimeter per second. Find the rate at which the volume of the water increasing when the depth is 2 centimeter. It means that depth of water means distance from O dash to A is 2 centimeter. Hence, distance of O dash A is 2 centimeter. O dash C is a radius. Hence, we can say O dash C is equals to radius. Here given that its depth is increases at 1 centimeter per second means dH upon dt. Here dH upon dt is equals to 1 centimeter per second, because H is a depth of water. The rate of change of depth of water, the depth of water is increases at the rate of 1 centimeter per second. dH upon dt is 1 centimeter per second. Also here we have to find rate of change of volume with respect to time t. Here the angle which is 30 degree, here the angle O dash is 90 degree, then we can say that tan 30 degree is equals to O dash C upon H, means opposite upon hypotenuse, O dash C upon H. The distance of O dash C is R, which is R by H. The angle of tan 30 degree is 1 by root 3, hence we can write H is equals to under root 3R. So here H is equals to under root 3R, or R is equals to H upon under root 3. Let V be the volume of water and V is equals to, we know that volume of water V is equals to 1 by 3 pi r square h. 1 by 3 pi r square h. We know that the value of R is equals to H upon root 3. We can write 1 by 3 pi into H upon under root 3 whole bracket square into H. We can write it 1 by 3 pi into H square upon square of root 3, which is 3 into H. 3 into 3 9 pi H square into H, pi H cube upon 9, which is V. So if we differentiate with respect to t, we can write differentiate with respect to t, dV upon dt is equals to pi by 9 into derivative with respect to t of H cube. If we consider H be a differentiable function in form of t is parameter, we can write pi by 9 into 3H square into dH upon dt. So which is 3 is 1 3, we can write pi H square upon 3 into dH upon dt, which is 1 centimeter per second. Hence the rate of change of volume with respect to time t is, when H is equals to O dash A is equals to 2 centimeter, pi into 2 square upon 3, which is 4 pi by 3 centimeter cube per second. 4 pi by 3 centimeter cube per second, which is a required rate at which the volume of water increasing when depth is 2 centimeter is 4 pi by 3 centimeter cube per second.